All right, hello everybody. We're in 3.3, and we're going to look at algebraically finding out if functions are even, odd, or neither, and we're also going to look at average rate of change. So to test if a function is even, odd, or neither, this is what you do. Replace x with minus x and you simplify. If you get back the exact same function, it's even. If you get the exact opposite, it's odd. Anything else is neither. So this is just like testing for symmetry. So let's take a look at a couple examples. Okay, so here's my first function. F of x equals 3x to the fourth plus 2x squared minus 3. So what I'm going to do is I'm going to plug in a minus x for all x's, and I'm going to use a parentheses. So I start writing until I get to an x, and once I get to an x, I replace it with a minus x, 2x squared minus 3, and then we simplify. So minus x to the fourth, this fourth power is going to turn it into x to the fourth, plus 2 minus x squared is x squared. And what do? We get the exact same function out. Plugged into minus x, I got the function back again. This function is even. It's never a bad idea to look at the exponents either. So here, these are both even exponents. I'm not sure if that is quite a coincidence or not. Let's take a look at another one. Okay, let's test this function for even, odd, or neither. So I'm going to plug in a minus x for all x's. Start writing until I get to the x. I replace it with a minus x cubed minus x, and let's see what happens. Minus x cubed is going to be minus 7x cubed, and here's a double negative minus times this plus, and then here I didn't get the exact same out, so I know it's not even. That's out, and what I can do is to figure out whether it's odd or not, factor out a minus sign. So if I take out a minus sign, this term would turn positive, and this term would turn negative. And now this is the original function back in. I got the exact opposite. This function is odd. Because once I pull out that minus sign, I have the exact same that I started with. So it's the exact opposite. That's what it means to be an odd function. Alright, let's take a look at one more. Let's take a look at this function. So one thing I forgot to mention on the last one is look at those exponents. The exponents give you somewhat of a clue about what it's going to be. So here I see an exponent of a 3, and I know that I can put a 1 in here. So my gut would say if I had to just guess at it, I would probably guess odd, because I look at odd exponents. But let's see what happens with this. So I'm going to plug in a minus x. It's kind of nice because it's the same test for both. Plug in minus x cubed plus 5 times minus x minus 4. And now I'm going to simplify. So minus x cubed is going to be minus x times minus x times minus x, which is going to be minus 3x cubed. It's going to be minus 5x minus 4. Okay, I know it's not even because I didn't get the exact same out. Now I factor out a minus sign. Remember, take it out of all the terms. So this turns positive, this turns positive, and this term turns positive. Is this the exact same as this? The answer is no. So it's not odd. This guy is in neither. What screwed him up was this constant term. If this minus 4 wasn't here, it would be an odd function. This isn't even, it's not odd, so that must mean it's neither. Alright, let's take a look at average rate of change. Okay, average rate of change. The average rate of change for a function f of x from a to b is given by, so here it's change in f over change in x, which is equal to f of b minus f of a over b minus a. This is what you should think. Think slope for functions. That's exactly what it is. Slope for functions. It is the exact same idea. So let's take a look at an example. Okay, so find the average rate of change of f of x equals 4x squared from 2 to 5. So this is like my a value, and this is like my b value. So here, my average rate of change is equal to, I need f of b minus f of a over b minus a. So what I like to do is off to the side here, I need, okay, well this is f of 5 minus f of 2 over 5 minus 2. So I might do this off to the side. This side works. So f of 5 is equal to, plug a 5 into the function, and see what we get. This is 4 times 25, which is 100. F of 2 is 4 times 2 squared, which is 4 times 4, which is 16. So here my average rate of change is f of 5, which is 100, minus f of 2, which is 16, over 5 minus 2. This looks like 84 over 3. 84 divided by 3 is 28. Okay, let's take a look at one more. Okay, so find the average rate of change of g of x equals minus 2 x squared plus 3 from 1 to 3. Okay, so here's my a and here's my b. So I know the average rate of change, I need g of b minus g of a, change in function value over change in x values. Okay, so off to the side, I'm going to figure out what g of 3 is. So I'm going to plug a 3 into the function. Careful here, square first, so this is minus 2 times 9 plus 3, which is minus 18 plus 3, which is minus 15. And, okay, so that's my g of b, so I'm going to write minus 15 minus. Now I'm going to figure out what g of a is, which is 1. So let's see, g of 1 is equal to minus 2, parentheses 1 squared plus 3, which is minus 2 plus 3, which is 1, over b, which is 3, minus a, which is 1. Let's look, finish off this fraction up top. We get minus 16 over 2. The average rate of change of this function from 1 to 3 is minus 8. And that is average rate of change.